We're going to go over a last hypothesis test. The hypothesis test is called ANOVA. If you've seen statistics in some of your courses for your major, you may have heard of ANOVA. We're going to dive a little bit deeper into the idea of it, besides just looking for p-values on this test. So in this class, we're going to examine ANOVA for the purpose of comparing differences between two or more means. In the last few sections, we had a hypothesis test to study one mean, to compare means for two different groups. Now we want to look at comparing the mean for any number of groups. Maybe we're comparing Democrats, Republicans, and independents on some measure. And emphasizing here, this is quantitative data, by the way. Since we're talking about means, which we evaluate on quantitative data. Maybe we're comparing some outcome amongst 5 different age brackets. Spending in 5 age brackets might be another thing we want to compare. So that's our purpose here. Compare means for any number of groups, not just using one or two like we've seen before. Our test we mentioned is ANOVA. It's an acronym that stands for Analysis of Variance. And when we're talking about analysis of variance and relating it to what we just mentioned, maybe a question arises. Our goal is to compare means. Is there some kind of difference in the means between these different age brackets, for example? However, we're doing that with a test that's talking about analyzing variance. Our goal is means. We got to analyze variance to answer that question or take a look at that goal. So there's a little discontinuity here we need to clear up before we look at how to do the test. Why do we need to look at variance if we're talking about means? So let's do that through the context of an example. In this particular example, we have this question. We're analyzing the relationship between fitness, physical fitness, prior to getting surgery, and all these people are undergoing corrective knee surgery, same kind of knee surgery. So check out how fit you are before knee surgery. They all undergo knee surgery, and then we're going to compare how long it takes how long your rehabilitation period is after knee surgery. And is that influenced by your prior fitness? So to do this, we've got 24 men in this study, young men 18 to 30. They're all having exactly the same knee surgery. And we have 3 different fitness levels that we're going to define: below average, average, and above average fitness. And we'll assume the researchers have very strict definitions and metrics for what places somebody in each of these 3 categories. Then we're going to assess how many days are required to successfully complete your physical therapy. So let's check out some familiar terminology here first. The response or outcome variable in this study. So in this case, we're interested in the number of days required to complete our physical therapy. So I'll just say days of rehabilitation after the surgery. That's the outcome variable we're comparing, and we're curious about the factor or explanatory variable of your prior fitness level. Does your fitness level prior to surgery influence how many days of rehab you're going to need? Now the factor levels, remember the distinction we had earlier in the semester. Factor is the variable of interest. It's going to influence the response. The levels give the details of the factor. So they tell us here they're classifying people according to some metrics into below average, average, and above average. I'm just going to abbreviate those for now: below average, average, and above average prior fitness. Okay. And then our experimental units, who or what, is being divided into these groups. They tell us we've got 24 males in that 18 to 30 age range that are being divided into these groups. All right, so kind of a review of that familiar terminology. And then we've got some information from this study. They tell us that the average recovery time for the three groups is going to be 38, 32, and 24 days respectively, meaning the 38 is our how long, takes 38 days on average for the guys in the below average fitness level to recuperate, 32 for the average group, and those that are really fit only took 24 days. So looking at these three numbers, we might ask the question, does this suggest the average recovery time is different in the three groups? I would say maybe so. It is suggestive of that in the way that we might think. The really fit people don't take as long. The less fit you are, the longer you're going to take to recover. Maybe there's some intuition to that. So maybe we'll add a little observation or comment here. I'll say the difference, or let me throw in a keyword here, variability or variance. Okay, so here's our first layer of variance or variability we're looking at, is these differences in the means for those three groups. So the differences or variability. Here's another keyword, between the three groups suggests that better fitness leads to shorter recovery times on average, or shorter average times. Okay, so that's kind of what's suggested by looking at the variability or variance or difference of the average behavior for those three groups. So that's kind of layer one we need to look at. And again, I'm going to emphasize this word here, between. That's a key word in ANOVA, the between variability. How much are the differences between my three groups in this example? Now, that's not the only difference we need to focus on. So I've got two different scenarios to highlight that. In these scenarios, you notice we have our below average, average, and above average fitness. And on both of these, the axes are the same. And the group mean is represented on each of these. Here's our above average at 24, average at 32, below average at 38. And then the same thing, same group averages on scenario B. So my question is, both of these have that same variability between my three groups, 38, 32, 24. The question is, which scenario, A or B, provides more evidence for an actual difference in population means? Which one, A or B, gives us stronger evidence that these differences here are representing true differences in the population? Right, hopefully you're thinking scenario A provides stronger evidence. And, maybe you're trying to think of how to word this. If you're looking at scenario A, these points are a lot closer, they're a lot more consistent with the group means. They're not as spread out as much. Scenario B, there's a lot more variability, so there's our keyword we're talking about, a lot more variability or variance or differences within each group. So it looks like here in B, this 24, 32, 38 could just be random. If I did this again, I might get something different. Here, it doesn't appear to be as random. It represents possibly a true pattern that's going on because they're more consistent, they're not as spread out within each group. So that's our second layer of variability. Let's write down some of this here. So I'll say something like this. Scenario A provides stronger evidence that the differences in sample means or I'll say that the differences between, emphasize that keyword again, between sample means. So just to remind you here of our notation, that would be our X bar for below average is 38. Our X bar for average was 32. And our X bar for above average was 24. So the differences in these group means for our samples. Scenario A provides stronger evidence that those differences represent true differences in the population and remember our notation here for population means. We used mu to represent the mean of a population, and we can just add our subscripts here. So mu with a subscript of BA for below average, mu with A for average, and mu with AA for above average. So we've got this one provides evidence that the differences between our means for the samples provide stronger evidence for differences in the means of the population. And let's write down our reason. I'll say this is because there is less variability. Again, we measure variability by the variance, hence analysis of variance. So there's less variability within, another key word, each of the groups. Okay, so let me just highlight to emphasize our ideas here, because this is going to be important and kind of the crux of building our test here. So we have the within variability and the between variability. And the between variability was highlighted in this first part up here, comparing 24, 32, 38. Between the groups, what do we see? These two scenarios compare the within variability. So this has less variability within each group. Scenario B, they're much more spread out within each group, more random within each group. So I'll just make the comment here, more variability within on this one. Okay, so more random, less likely to represent something really going on. All right, in the next video, we're going to formalize all this into our actual test, and we'll check out a few examples after that.